WebEx isn't showing to me. 179. So it seems to be a pretty good crowd. Seems like it's time to get going. I just posted into the Jabber the link directly. I see some people are having trouble with some of the media materials, getting them downloaded successfully. I don't know what the problem is. I do know the individual slide material is directly available under the ADD group webpage in Data Tracker under meetings and then the meeting materials for this IETF 107. You can directly download them there, or you can just watch your screens and play along at home. So welcome to the first meeting for ADD. Couple points. This session is recorded. Please make sure your video is turned off at home. Mute your microphone unless you are speaking. If you want to join the queue for comments, please put a plus Q. I'm getting a message here from somebody. Please put a plus Q into the WebEx chat session. If you want to get out of the queue for speaking, when we open the lines, put a minus Q, and we'll keep track of that and call you when it's your turn. As well, please do not use the WebEx chat session for conversations to the whole group. For that, either use Jabber or use direct messaging between people. We're going to try to keep the main chat session in WebEx for managing the queue. So up there on the screen as well, we have the pointer to Jabber and to the Etherpad. Barbara Stark has volunteered to be a scribe in Etherpad. If there's somebody else who would like to join her and help her out, because these ADD sessions in the past have gotten pretty busy and quick. Is there somebody who'd be willing to help Barbara out in the Jabber? Okay, I see one person in Jabber commenting. So okay, so we got some people in Jabber. We got some people in Etherpad. I think we are set to go. For those who haven't read the instructions for the remote participants, the way we're doing blue sheets is for people to go into the Etherpad, and at the bottom of the Etherpad, you'll find a list of names and affiliations. Go ahead and add yours to that list, please. Okay. So moving on, and bear with me, first time we've done this. As this is an IETF meeting, albeit our first virtual one, please note that NoteWell does apply. And please be familiar with all the requirements of participating in an IETF meeting. And welcome to IETF 107 ADD Virtual Working Group. We're going to go for the next 2 hours and talk about the wonderful world of discovery and conveyance of information about resolvers to clients. This is our agenda. David Lawrence and myself are your chairs. We'll have an agenda bash, followed by, I believe Ted Hardy is going to speak to the draft he and Yari have put together, talking about distributed resolver selection. Then Tommy Pauly will speak on discovery selection directions. Dan Wing will present 2 different working drafts. Then Daniel McGill will be our last one, and then we'll have hopefully have 15 minutes left over for some Q&As. So since we can't see each other, I thought you might like to see who to blame. There's myself and there's David. And there are the links to the Etherpad and to the Jabber. I'll give everybody a minute if they want to grab that. They're also going to be on the other slides. So any comments, any things that people would like to alter, change on the agenda? Speak up by adding your plus sign to the queue or commenting into the Jabber, please. Okay. Hearing none. Let's move on. So welcome to ADD. This has been a long time coming. We've had a couple of BOFs that touched around the topics of where ADD eventually ended up. This started out as sort of a very DOE-centric discussion. It's evolved, I think, to cover a sort of more generic discovery of encrypted DNS provided resolvers, whether they be DOT or DOE. So we're not DOE-centric, we're equal opportunity. The charter, as it got developed over the last few months, went through a lot of changes, and so I invite everybody to become familiar with where it ended up. It's a very narrowly scoped charter. We're specifically focused on the questions of how do you discover resolvers, and also chartered to develop a mechanism for resolvers to convey information back to the client such that the client can use that information to make decisions on where to, which resolver to pick. We're not here to talk about policy. We're not here to talk about UI interfaces in the clients. All the other kind of stuff is out of scope. We're really limited to the technical nuts and bolts of discovery and conveyance of the information. The rest of it's left up to somebody else at the moment. So with that said, Dave, do you want to make any comments?
Quickly, you already covered a little bit of how we're managing the queue. I wanted to add the additional note that we'll save questions for the end of presentations and not really be able to do an interrupt queue. And when you request in WebEx chat to be added to the queue, if your handle does not reflect your full name, could you please include your name in your queue request? Thank you.
Thanks, Dave. And Barry, did you want to say anything?
No, I think you've done well. Just carry on.
Okay, thank you, Barry. All right, well, let's get to it then. So Ted, I have not seen you on the system, but I haven't checked yet. Are you around?
I am here.
Okay, I'll bring up your presentation then.
There is a missing picture there. This is also work that Martin Thompson contributed to. So if you haven't seen Martin Thompson recently, he can send around a picture on his own, I guess.
Okay, Ted, so just let me know when you want the next slide hit, and I will do it.
Okay, as the agenda noted, this is based off a draft that Yarko, Martin, and I have been working on. Next slide.
1 second.
And so this is the key question we're trying to ask here, is can you reduce the concentration of information about client activity by distributing across different resolver services? And the reason we're talking to you about it, even though it's not strictly about conveyance, is it goes to the question of how many of these might you collect if you are a client that is looking for DNS services or trying to gather information about DNS services. Clearly, if you need to collect in order to accomplish a particular strategy more than one, knowing that and knowing why you might use more than one DNS resolver is important. Next slide, please. So this is what we believe is a set of common DNS resolver selection patterns. The first one is there's a single configured resolver and all queries go to that. The second is there is a resolver used for all the local interfaces, but a separate resolver configured for VPN interfaces. The last is that there are per interface DNS resolver lists. It's our intuition that these are kind of roughly ranked in terms of commonality, but I'm afraid we don't have any data to share that would either demonstrate that or tell you what the approximate numbers are for each one. That's just kind of our rough understanding. Next slide. And this is sort of what happens when you have this set of configured resolver, what the query patterns look like. So in the first case, there's one configured resolver, so that resolver knows everything about the client's query traffic, but no one else does, and that's an important thing that didn't quite fit on the slide. In the second case, there's a resolver used for all local network interfaces, but a separate resolver configured for VPN interfaces. In this case, the common resolver gets all the query traffic except for the VPN, and the VPN gets all the traffic passed through the tunnel. In the per interface DNS resolver list, it does exactly what it says in the tin. Each resolver gets queries only for the traffic on that interface. And if you said split DNS for item 2 and cell phone for your breath for item 3, collect a cookie. Actually, make that 2 or 3 cookies in the common case. And next slide, please. So what are the privacy implications of these common approaches? Well, one thing that's fairly obvious is that if multiple ones of these resolvers configured, sent all of a specific client's queries to all of the resolvers available to it, then all of them would know about all of their resolution events. That clearly is not going to be the best way to reduce the information being leaked out into the world about the client. There are a few clients that actually do this, primarily ones which have no bandwidth constraints and very requirements. But it's not really a very privacy-focused view of how to do this. In the second case, the send all queries to one resolver, that obviously, and that resolver seeing everything. If that's a resolver that you believe is not going to leak that data further, that can be an appropriate approach. And having a separate resolver for VPN interface avoids queries via that network leaking, right? So if you don't want the information on what's in the network VPN leaking out into the world, that's a useful thing to do, but you're probably still going to get a whole bunch of information going to a single resolver. So politicalparty.org, recreationalhabit.com, and traveldestination.info are all still probably going to the same resolver. It's really only your workplace, as example in this, that's going to get separated out. And the privacy implication of the interface list depend on how among the interfaces. Next slide. So, can different resolver selections improve privacy? Different approaches than the ones above. Next slide, please. Maybe. And you can see that tentative about this response. Next slide, please. It's pretty clear that carefully selecting the resolvers to include in the candidate set for their privacy properties will help. So, for example, if you're concerned about queries being visible on the wire, then select that offers DOT or DOH is clearly an advantage. And if you have knowledge of their policies, selecting ones that match your policies are also potentially useful if their privacy properties are included in the policies. But a whole bunch of trade-offs, and we kind of go into them a bit in our draft. And it turns out not to be at all simple to devise a system that in every case is going to improve the privacy of a client. In fact, the trade-offs may mean that by protecting the privacy of a single client, you may be reducing the total set of clients using a specific resolver and thus having implications beyond one client. Before going through those in detail, and in fact, we're probably not going to go through them in detail today at all, we wanted to pose these questions to the work. And next slide, please. And this is sort of the basic, is this the right place to solve this problem set of questions? Is the working group willing to consider approaches that result in multiple DNS resolvers being discovered? Because if the answer to that is yes, then we can keep talking. And if the answer is no, that's not really in scope, or we as a working group don't want to work on that, then we'll have to find other places to socialize this work. The second question, if the answer to that does turn out to be yes, is the working group willing to consider optimizations in the concentration of information about client activity? And that's a different optimization than some of the ones we've already discussed. And so it's important to recognize that this is going to involve some trade-offs that the working group would have to discuss if you take this. And the last question is the working group willing to work on describing the operational impact of those optimizations? Because there definitely are some operational impacts. And I understand that we're going to take up these questions with the rest of the questions to the working group at the end of the session. So I think that's it for me.
Thanks, Ted. Okay, next up is Tommy Pauly. Tommy, you on?
Yep, this is for my being in queue, right?
Actually, we're gonna take. I think we're gonna do big questions at the end. Is that right, Dave? Or do you want to do them now?
No. Like after each presentation.
All right.
And we still need the proximity to what people were just talking about, I think, to have important contextual awareness. So,
Okay, so I'm gonna turn over to Dave, who's gonna manage the question queue for Ted's talk.
yeah. And so first up is Tommy Pauly.
Right, that's where I was confused. Okay, thank you. Thanks, Ted, for sharing this. I think it's a really good overview of the question space and how this interacts with privacy considerations in a way that goes further than what the charter discussion was. I have one point and then a kind of response to your questions. First, just as like a nit, when you have the ordering of the types of resolvers that you find to be most common, you listed, having the one resolver that we use for everything on the device, followed by the split VPN case, followed by the per network case. At least in my experience, I would actually expect that the per local network resolver is going to be the most common, at least as the default for most client operating systems. This is definitely true for iOS and Mac. I imagine it's the same for Microsoft operating systems. When we're on both a Wi-Fi and a cell network, the queries on those different interfaces use what is provisioned locally. And that's really important for a lot of the local network interactions. So I think we should view that kind of as the status quo. And if that's not being done, when we are selecting just one resolver for everything, regardless of the interface, that's breaking a lot of the recommendations about provisioning domains that came out of the multiple interfaces group. Then to your questions regarding, should we consider approaches that result in multiple DNS resolvers? I think absolutely yes, we do need to be concerned about that as a group. I think it's fundamental to the discussion in the charter. If we're only interested in getting one thing, we're missing a lot of the nuance about how to interact with the network. And to the point of reducing the concentration of information, I do think that is very useful, but I would challenge us to, when we are looking at that, to consider the privacy impact and the data leakage, not just in the resolution flow, but in the subsequent connections, because that's kind of a whole package about what information is getting out. If we don't consider how we send our names in TLS, SNI, et cetera, then we're missing the whole picture. Thank you for this.
Thank you, Tommy. And now Mohit Sethi, please.
Hi. So Ted, thank you for the presentation. My question was about the interface selection. So I'm assuming that what you mean by interfaces, if a device has multiple interfaces like Ethernet, Wi-Fi, and mobile broadband, then you perhaps use different DNS resolvers for them. I guess there needs to be some more detailed information, like is it fine that you discovered the DNS resolver on that interface, but that interface is no longer up? Because most stacks currently allow you to only have one network interface up at a time. I know there is MPTCP and so on, but even though the laptop I'm currently using does support all three, I'm currently connected only with mobile broadband. So I think perhaps some more explanation whether that interface needs to be up, or like, can I also use the DNS resolver that was discovered when the interface was up in the past, but is no longer up and running, and I'm no longer sending traffic on that. Yeah, I guess some more explanation would be useful.
Thank you. Improve the language in the draft around that. I think the primary thing that we're trying to get at, though, is if you have multiple interfaces, which has a different DNS resolver associated with that interface, it could be the large-scale case of a split DNS, right, that I think Tommy was referencing, where each one of these interfaces might have names that are available only via that network, or have characteristics that are only accessible through that network. So you would associate the name resolution to a specific network interface using that. I think we anticipate ADD coming up with different strategies than the ones we've had in the past for discovery of DNS resolvers. And then the question becomes, does that set of mechanisms take this potential optimization into account? And I think if there are different mechanisms being developed, we might not end up in the situation where the answer to your question is particularly obvious. So I think we would have to work through that and get the work up.
Thank you, Mohit. And now Ben Schwartz, please. I just want to make also a quick note that I'm gonna close the mic queue after Warren, who had just signed on, and because we're going to try to get the next presentation, keep it on time at 1:30. You're up, Ben. Okay, I'll drop Ben down one in the queue if Pete Resnick is ready to talk. Oh, yep, Ben just said in chat that his mic isn't working right now. So Pete, can you come on while Ben tries to get that sorted?
You bet. So one suggestion for the draft and then a question. The suggestion being, and especially given what Tommy said, thank you, Brain, about the ordering of these things. It does seem to me that the VPN case is basically subsumed by the multiple interface case, because what you're talking about is the multiple interface case, but one of the interfaces happens to be a virtual interface. It's acting almost entirely the same as the common case for multiple interfaces. So I don't know that you necessarily need to separate those two out. Maybe you want to make a separate claim about with multiple interfaces, there are two ways to deal with them. One is to ask them all the same question, and one is to ask only, particular ones for particular cases. But I think it's worth having a go with that. As far as my question, if the working group does answer yes to the first question, that they're considering these kinds of different approaches, what do the authors here want to have happen? That this is a working group document that is sort of like a use case document, or is this just a standing draft that eventually will go poof and once the protocols are developed? Or it doesn't seem to fit into charter, so I was wondering what your plan was.
I want to know if this is an appropriate discuss the draft, right? And so if the answer is that we develop in the course of that discussion ends up in driving some aspect of the protocol, that's a great result. We may or may not want to publish the draft. It sort of depends on what the output is. Certainly possible that one output is we discuss this and discover that the answer is that this optimization is not something that we're actually going to be able to achieve, and recording that somehow might also. But I think it's primarily, is this the working group mailing list we're going to talk about this on?
Cool, thanks.
Yeah, thank you, Pete. I'm waiting for Ben to reply that his mic seems to be okay, so I'm going to skip ahead now to.
Me now?
Oh yeah, we can. Okay, great.
Okay, well.
Schwartz.
Thank you. So I haven't heard the other responses, but on the questions as phrased, I would say yes, the working group should consider approaches that result in multiple resolvers being discovered. I think that's unavoidable. Is the working group willing to consider optimizations for reducing the concentration of information? I think that the word optimization implies the ability to evaluate an objective function, to tell up from down. And I think we really don't have that level of understanding about the implications of where these queries go. So instead of optimizations for reducing the concentration, I would just say configurations that alter the concentration and leave it to a future group or to users and implementers to determine what's optimal. And on describing the operational impact of those optimizations, similarly, I think that we should not speculate. We can certainly describe obvious interactions with other existing systems, but I don't think that we should guess at higher order effects that they're likely to have. I do think that there's real potential work here for the IRTF Privacy Enhancements Research Group to try to figure out what happens when DNS queries are distributed or concentrated in different ways. Thank you.
Thank you, Ben. I just want a quick note. We have 5 people still left to go in the queue, and we just hit half past the hour. I'm not going to cut you off right now, but if you could please keep your comments brief. We do have a little bit of buffer room built into the schedule. And so for kind of extended thoughts that might occur, let's save them towards the end of the meeting. Thank you. And so next up is Sanjay Mishra.
Yes, this is Sanjay. Hi, Ted. Thanks for the presentation. And I think the questions that you have, all 3 are very valid questions and something I believe fits with the charter of the group. So certainly the group should be looking at all these 3 important issues. I have looked at the draft earlier, but I have to look back again. But I wanted to ask if you have had chance to see how the distributed resolvers would impact on the latency on the queries.
We're not currently in the draft at all, to be honest.
But okay, I get it. So is this something that should you move forward with the draft? Is that something that would be considered as part of the overall approaches, given that this is talking about distributed resolvers?
So I think it definitely would be by the work of the working group at some level, but I'm not sure that it would be distinct in looking at this as opposed to part of the overall set of work items of the working group to consider when you're resolver for a particular policy characteristic and there's a really pessimal latency impact, what do you do? I think that's a question that the working group will have to answer more broadly than just in this context.
All right, thank you.
Okay, just to keep things moving, because Chris might be having microphone problems. Eric Rescorla, please.
So I think that there's a bunch you're sort of raising here, Ted. I think there's an interesting problem in here trying to climb out of the presentation, which is, say you have a bunch of apparently equivalent resolvers, how ought you to manage your queries for privacy? And I think that section of the draft is pretty interesting. And in particular, a lot of things people obviously might want to do are really terrible. So it's really good to have that pulled out. I guess I'm not sure I'm as interested in the questions you're raising on this slide, in part because some of them seem like not really the questions that this draft raises. I think the best place for this draft would be to be an analysis draft, which is the analysis draft answering the question which I just indicated. I think the sort of the questions of where the drafts are where the resolvers not really equivalent is really hard to think about, and I'm not a huge fan of trying to reason about it. I just want to flag, Dennis, Ty Polly said, we should think about treating the network resolver as the default. Please don't say that. That's just status quo bias about the fact the way things have historically been, not the way things necessarily should be.
Thanks for the feedback, Ecker. I'll just note that there are some cases in which we can't really assume that the set of DNS results are equivalent.
I agree.
The VP, yeah, and so you may have 2 different things you have to worry about. Is this a condition in which I have to go to a resolver because it's the only one that can give me an answer, which is a classic split DNS problem, or okay, now I don't have that problem, and now in the second stage of analysis of where I'm going to send this, I can now take into account the meaning set I have determined are equivalent either from the fact that they're all or they're or whatever it is it's going to cause them to be equivalent. Basically, that they're all going to return the same answer to the same query.
Sure.
You agree with that this two parts of the
Yes, I agree that there are those two parts that I'm not sure if people can hear me because I was getting glitches, but I agree those are the two parts of the tree. I guess I'm suggesting focusing on the second one, not the first.
Okay, great. Thank you. The last in queue right now, Jim is going to hold his questions to the end. So Chris's microphone seems to be fixed now. Chris Fox.
Yep. Okay, right. So I was going to say +1, yes, I think this is a topic that needs to be explored by the working group. On the list, I was trying to make a couple of points. The first was that using multiple resolvers implies multiple privacy policies. So if the user was to rank these in preference order, and using more than one implies you're accepting the second best and the third best and so on. Yeah, so we've had some discussion about, yes, well, all of the ones that we're looking at are good enough, but I think it might not be so straightforward. The second point is that the current model of using a stub resolver in the home requires trust in that forwarder, but outside the home, all recursives have no visibility of the individual clients inside the home because they only see the aggregated view. Moving to clients using additional resolvers outside the current network implies sharing that per client identification with those resolvers. So that's a privacy loss in some sense. Whether it's an issue, it needs more exploration. But I do accept that if the local stub resolver is insecure or compromised, yes, that's an issue. That's a big issue. So that's it, really.
Great. Thank you very much, Chris. And as I said, Jim will hold his comments to the end. And so back to you, Glenn.
Great. And thanks, everybody. I'd just like to remind people, we seem to be missing a few people on the blue sheet sign up in the Etherpad. So if you're on, please go there and sign up with your name and affiliation. All right, Tommy Polly, you're the next contestant.
All right, thank you very much. So this is going to be an update on some of the thoughts we've been having around draft that we presented last time in dprive and in the ABCD BOF. I apologize, I haven't actually updated the draft yet, but I did want to have this discussion, especially in light of some of the stuff we were talking about in the last presentation. Next slide, please. All right, so I mean, the goals that we have in this, which I think align very much with the goals that we've described in the charter, are that we want to be able to discover that resolvers are there, regardless of how many we use. And we want to discover them both locally and remotely and discover that they can do DO or DOT, etc. And we also want to figure out information about the resolver, information that can help us decide as a client when to use this resolver, if we have multiple available to us, and if there are any special capabilities of this resolver. Are there names that it claims split DNS capability for? Are there things that we have to do in order to get through a captive portal, etc.? Next slide, please. So I just drew a couple pictures here that can help us talk about this area. So here's what I'm describing as like a status quo model. We have multiple devices. They each have their own local DNS server. If they're on the same network, this would be the same one. And they're reaching out to different websites or other resources as they're resolving these names. Next slide. So when we go to a model that we have kind of one or some centralized list of trusted remote resolvers, we imagine now that we are not using local infrastructure, we have some remote DO server or DOT server as it may be. We do all of our resolution there, and then we get to the same servers at the end of the day. So this definitely has some benefits of not exposing names to the local resolvers, but as was brought up in the last conversation, maybe this is centralizing more information onto that one server, we need to make sure we can trust that external resolver pretty well. And it also doesn't change any of the stance about what is exposed about the end web service that we're getting to. Next slide, please. All right, so we can also have multiple servers. I think when we talk about multiple resolvers here, there's a big question of how do we know when we should use them if we have multiple. There are different strategies that you could take. You could just distribute it. It could be up to the client. But next slide. What we are discussing in this document is trying to couple the notion of which resolver we use with which names we're trying to access. Now, this does require some bootstrapping or figuring out what your names are in general. But when I'm accessing names within a particular domain, let's say for example.com, and I have lots of sub-resources on example.com that may give more information about what I'm doing, it seems like one of the best privacy stances and efficiency stances in general is to have that information centralized with the entity, entity in quotes, that is actually going to be serving that content, because it is both authoritative for it, but also is already going to be receiving my connections. And so the amount of data for granular lookups that's being leaked out into the world is minimized. Next slide, please. All right, so this is one approach you could have to how to use multiple remote resolvers. So in general, why are we interested in designating, as we're calling, resolvers for domains? So the argument here is that having the same entity terminate your TLS or HTTPS connections, also terminating your DOE, gives you good benefits. It does reduce the number of entities that's seeing the names that you're accessing for a given client IP address, assuming that you have to talk to this server anyway at the end of the day. And while it is true that this entity that you're resolving to is going to see many resolutions for things under example.com, for example, it's also the entity that is serving the names, or is at least related to that entity. So it's probably aware of these clients anyway. It also becomes easier to have optimizations later. So if we want to be able to have a client upgrade its connection from a DOE connection into a normal TLS connection, let's say Google at some point was able to do DOE onto one of its servers, and then I could just upgrade it into another connection. Having a notion in which I know that I should be doing my resolutions to the server is a beneficial thing. So next slide, please. So the way that we are talking about discovering, as we presented previously, is by advertising the existence of these resolvers in DNS records themselves. And this is a relationship in which when I do a resolution and request a record, in this case, a HTTP service record or a service binding record for a given domain, it can include a DOE URI template that it knows is authoritative for that domain. And the reason we're using this is that it's the same mechanism that we're already going to have to request for getting the encrypted TLS client hello, the ESNI previously, that's being renamed. So if I'm already requesting that, it's nice to bootstrap, also knowing that there is a DOE resolver that I can do for more specific queries in the future. And note that this is kind of involving a bootstrapping step. So either I'm doing this request on the local resolver to a trusted remote resolver, or via some proxying or oblivious method. And then similarly, we need to be able to discover local resolvers. And the proposal here is to use extended information on the provisioning domain, which comes from your RAs or DHCP, to get a notion of how to access your local resolver in encrypted fashion. Next slide, please. All right. So as far as getting resolver information, the proposal here is to have information that we can get specifically from a DOE server off of a JSON blob that we're just using the provisioning domain existing blob here. So if we access a specific well-known URL off of that server, specific to this DNS URL template, we can get more information that can be extensible about this server. This information can include the URI template itself. That can be useful when you have a local PVD that tells you here's my DO server. And it also allows giving hints or information about split DNS and other domains that we want to include. Next slide, please. All right, so this designation does need to be trusted in some form, and that's what I want to spend the rest of this time going over. If we do have DNSSEC signed records, that we believe is a good indication that the owner of this domain and the entity managing it is aware of the DO server or the dot server that you are designating, and therefore we have some reasonable reason to believe that this designation should be trusted. And this could be done on the local network as well. So if your local network actually did own Comcast owned Xfinity namespace, they could let you know that the local resolver was indeed authoritative for that and designated. However, we have certainly gotten a lot of feedback, and we recognize that it's not always possible to deploy DNSSEC easily, especially for very large deployments that may come at some point, but that's not an easy bar right now. So we've been looking at other mechanisms to get a similar form of trust. So in the same way that we want to have a relationship in which the owner of the name is kind of pointing back to the DO template or whatever other encrypted resolver you have, we want to have some proof that the owner of this name is pointing back. So the proposal here is that we could have in my extended information about my resolver a hint that it claims that it's designated by example.com, but then we can go independently do a separate resolution for the top level domain of example.com without using the DO server at all, fetch it, do TLS to there, and if we see that indeed a well-known URL at example.com says, yes, this is my DO server, then we have some reason to trust this. It's more round trips to do this bootstrapping, but it can get a similar effect to DNSSEC. Next slide, please. Next slide.
Yeah, I'm working on it.
Sorry.
It's Tommy, that's all the slides for your deck, Tommy.
Do you know?
Do I have an older deck?
No, I think that I can. Let me try to resend it to you.
Oh, hang on. Well, hang on. It says page 10 to 15. Give me a second here.
Yeah, there should be just more diagrams at the end.
Yeah, preview is being difficult.
Uh-oh.
It doesn't want to advance the next slide. Hang on.
If it's not coming up, it's not critical. It's mainly, it was just some diagrams to explain that last point.
I have to restart preview. Give me a second here.
Okay.
I'm going to kill preview and restart it because it doesn't want to advance to any next slide. So give me 1 second, please.
That's good.
Okay, I'm making a play option here that as long as Glenn, oh, maybe he's ready.
Almost there. Yep.
Okay.
Nope. Doesn't want to advance to the next slide. Give me 1 second. Let me see what's going on.
Okay, well, we have a couple in queue right now. So while you're fiddling with that, Eric Riscorla, did you want to jump in with your first comments here?
Yeah, I mean, this is cool. I want to make 2 points, one trivial and technical and one more substantial. The trivial and technical one is you indicate that this is the same information as is needed for ESNI. And that is at some level true, but at some level it's false. And the level at which it's false is that ESNI does not really require the data to be authenticated. This is kind of counterintuitive and is covered in the draft, in the SNI draft quite a bit, but the executive summary is that once you control the DNS, then like the SNI information is effectively lost because you can, like, for instance, return a unique address for every SNI. And so having the SNI crypto keys authenticated isn't very important, whereas that's not true here for such obvious reasons. Because you're for instance detouring the traffic from your from one place to another. The more relevant point or more larger point, and I think I've talked about this before, is that this seems to have some really quite severe failure cases. And so, for example, imagine you have a domain served by two CDNs, A and B, and ordinarily A would get 10% of the traffic and B would get 90% of the traffic, and you use Sidexis, for instance, to swap them, right? So what happens is the structure of this is basically that because you're pinning people to whatever they happen to get, if the CDNs both do this, it's very easy to end up in a situation where basically temporary traffic shifts persist and are hard to fix. In particular, like imagine B's down and A is covering all the traffic, then like almost impossible to get the traffic back to B until like all these things expire. So I think I floated this to you before, and so I guess I'd like to understand how you think you're going to fix that, or maybe that's just something that the working group has to work on.
Okay, and before you do,
Thank you for bringing that up.
I just want to say, Glenn, it looks like you're back online and working. So after you continue with your response to Eric, Tommy, could you then just run right back into your slides?
Absolutely, absolutely. Thank you. Yeah, so thanks, Ecker. To the point about ESNI not requiring DNSSEC, that's absolutely true. I think my main reason for bootstrapping this on the same thing is just that it's a request we have to make. Requesting DNSSEC information doesn't hurt even if it's not there.
Agreed.
Yeah. For the other point, could you just repeat the last bit again?
So yeah, so I mean, so my assumption is that the way we'll typically deploy this will be that that every person in the limit, every large like service provider serving any domain will want to advertise that it will handle the DNS resolution for that domain, right? Because that's where you get the maximum privacy benefit. So imagine you have a situation where example.com is served by CDN A and CDN B, and they both advertise records that say, hey, look, I'm like the person who's responsible for this, right? And that's especially obvious in the HTTPS case, which you indicate here. And so my concern is that makes the traffic allocation at any given time extraordinarily stable and hard to change. So in particular, like say all my traffic goes to CDNA, and then I went to a new CDNB. Well, that takes a long time, so all these records have to expire. So I think we need some story how to deal with that. I'm not sure what that is, and I'm hoping you have one. But if not, I guess we'll have to work on one.
So I think that's something that I do want to get more input from the group on. I see two different deployment solutions to this area. One is that a given entity that is distributing its traffic between multiple CDNs could have one single notion of its DOE resolver that's in charge of splitting the traffic between the two. That's kind of like this virtual entity that's not necessarily the CDN itself, but some intermediary that's working on behalf of the domain owner for both sides. But alternatively, there's no reason that when I request a HTTP service record for a given name, it can't have answers back to me of saying that it actually has two different designated servers that both check out, and perhaps we use the priorities in those records to kind of do the weight balancing of who's going to where. So I think there are different ways we can look at it, but we'd want some more CDN input on the details here. All right, so to finish the slides out, this is just demonstrating the scenarios that we have specific to the DNSSEC validation or the lack of DNSSEC. So in the case in which we are able to get a DNSSEC signed record that says example.com designates the valid DO server, everything's fine. We can do our DO queries directly to that server for everything under example.com from then on. Next slide, please. The concern is that if you have unsigned records, we of course can't trust those because anyone could just put example.com designates attacker DO server, and then all of a sudden I use that and you're redirecting my traffic. Next slide, please. So the mitigation that we're talking about using, which does have more round trips, is that I have an unsigned record for example.com. It says, if it says a valid DO server, I can connect to that DO server, not request any user traffic, but simply do an informational query onto it to get its blob. In that it could say, yes, example.com's trust me. We then go do a query separately using another DNS resolution source, find example.com, and validate that example.com indeed designates the valid DO server. Next slide. So the attacker case, in this case, we would, if they tried to do the same thing, unless the valid server with the TLS cert for example.com did designate the attacker DO server, it would break the chain there and we would no longer trust that. Anyway, so that's just a helpful diagram for people. And other questions, and we can wrap this up. I don't want to take too much time.
So you're up now. Puneet, please. Puneet Sood. Okay, because we have a lot to talk about. I realize people are having mic issues and all, and as with previous cases, you'll just get bumped down in the queue. Hopefully Eric Nygren's mic is working.
Is this mic working? Mic working?
That sounds like, was that you, Puneet?
So I was saying that to Ecker's concern about the multi-CDN case, one approach would be for the name that you...
Just let me interrupt you quickly, Eric. I just want to be clear for the note takers. This is, in fact, Eric Nygren speaking.
This is Eric Nygren speaking. Is it to Ecker's concern for the case where you try to have the well-known PVD file, that domain you can set that on, if there's a way to do that based upon the name that was in the service domain name of the HTTPS service record, so the target of that, since that would be distinct per CDN, that might address that issue. I'll put an example into the Jabber chat.
Great, thank you. Tommy, do you have a response or?
That sounds good. Thank you for sharing that, and we can discuss offline.
Okay, Puneet, is your mic going yet? Okay, on to Andrew Campling, please.
Hi, is my mic working?
Yep, agreed, Jay.
Yeah. Hi, Tommy. Obviously, I think it's a very sort of slick way of doing discovery. The one thing you didn't touch on in the presentation, how would I, as a user, express my preferences? Because at the moment it looks like the machine's taken control from me. If I want to curtail it from just going wherever it wants to, how might I say I only want to go to particular resolvers or only those with particular policies, rather than let it fly wherever it sees fit?
Yeah, that's a great point and a great question. I think that is something that the working group does need to talk about, and I think, well, it's like the item 3 on the charter kind of covers that. What I'm talking about here is purely about the discovery and discovery of information, not at all how it's used. I think the client always needs to retain the authority to ignore the information. It's always going to have that ability. So I think that's a follow-on discussion that we need to have.
Okay, thanks.
More try it, Puneet. Okay, Ben Schwartz, please. Ben, I know your mic was working last time. Okay, Puneet and Ben are bumped down. Just Ralph Weber, please.
Hello, mic check. Can you hear me?
We read you.
Okay, so one of the things that you actually do with that draft, and I think we discussed this before, is that the resolution this part is kind of pushed back to the client, or the client is doing the resolution part. There might be some situations where this actually kind of distributes more information about the client than in the current scenario, because if you ask for everybody up the chain pretty much, if you ask them via a regular resolver, what the authority for that gets is the IP address of the resolver, whereas in this case, if you have a DO or dot server at a higher level domain, then you'll get sort of all the queries from all the clients, so you can actually connect the client kind of population and do something with it. That might be something to think about, to maybe improve on.
Yeah, and that's definitely a good point. That's why to the earlier discussion we're having of, when do we distribute our resolutions, I think we need to take into account both which resolvers we're using, but also the ultimate connections we're making. So if you were doing resolutions without ever making connections to the same entity, I think that definitely is a problem. I think if we can have a way to limit it such that for the names under google.com, I only am talking to the Google DO server, it presumably is already in a place in which it's receiving these TLS connections later. So hopefully it's not able to gather more information because it's about to receive those names anyway. But that's something to continue to be concerned about.
Yeah, I mean, DNS has sort of not infinite, but can have very long trees. And while we are used to sort of having top level and second level, there are other deployment models also where the kind of trees are deeper.
Thank you, Ralph. Puneet is finally back.
Hi, second try. Can you hear me?
Okay.
So Tommy, I'll try to be quick. So the question is, this works well when the DNS and the web servers are operated by the same entity. But for smaller providers where they've outsourced their DNS, this would actually result in providing more information about the client to different entities. And my concern is that the large websites are generally public, so no one cares if I go to google.com or apple.com, but they do probably care more if I go to a less popular website. So I'm not sure there'll be a net improvement in privacy for the client.
Yep, that's definitely a good point as well. I think for the case in which you have a small website that is being run on a CDN, like let's say I have something, a one-off website that I'm concerned about, and it's running on Cloudflare, it's running on GoDaddy or whatever. In those cases, if the entity that is authoritative for the resolving and the connections is that CDN rather than your particular website, that may have good properties. But yes, if you are running your own server completely independently, then we do need to be concerned about that case.
Okay, and just a quick note from the chairs, we have used up a lot of our buffer in this session. So we will finish with the 2 comments from the current mic line, but please keep this in mind for the following presentations. So first, relaying from Ben Schwartz on Jabber. I understand how the scheme improves privacy when combined with oblivious DNS, but in the absence of oblivious DNS, which is out of scope for ADD, I think this is only a privacy improvement for certain assumptions about TTLs, and some queries will leak when TTLs expire. I'd like to see those assumptions clarified and see if there is a simpler solution, such as using long-lived CNAMEs. I also want some consideration about whether these long TTLs are a tracking vector.
That's a good discussion, and that's one that we've been having, and I think we should continue on our GitHub and in the group.
Awesome. And for the last question now, or comment, Warren Kumari, please.
So thanks for the mic. This is Warren Kumari. So someone, I think it was Tommy Pauly, said that we should only use the Google resolver for Google names, which initially sounds like a grand idea, except that I don't know what a Google name is. Right? There's google.com, there's Google user content, there's Gmail, there's thousands of other names. And so unless I have a way of knowing beforehand what name should be mapped to a resolver, I can't do that. And if I know what name should be mapped to a resolver, I don't need to ask the question because I already know the answer. So I think that that's something where this sort of scheme needs a lot more discussion.
And I think that's the bootstrapping question. If we have some oblivious mechanism that we're doing the initial resolution over, then that's slower, but we can trust it. Alternatively, there's nothing stopping you from having a, let's say one trusted resolver that you use for your default queries that you think has good properties, but then once you learn that, oh, this domain I didn't know about actually is a Google name, then you switch it over.
Awesome. Thank you, guys. Thank you, Tommy. Back to Glenn to push on to the next.
All right, so our next session is going to be Dan Wing, who's going to talk about two different drafts. So Dan, you on?
Yes, I am.
Okay, I will bring up your thing and you're on.
So my name is Dan Wing. Next slide. We're going to quickly talk about, I got a 20-minute slot. I'm going to try to give some time back, quickly talk about the outline of this draft and where we're trying to go with it. Next slide, please. So our scope for this draft is how to discover DO and DOT servers on a private or local network. We're concentrating first on home networks. We have a separate document that we're working on for enterprise networks, but we wanted to hit the home networks first. It's most relatable. Next slide, please. So again, we're just doing home networks. Enterprise networks are out of scope. And we're talking about server discovery mechanisms and the steps required to get them bootstrapped. Next slide, please. So this is showing a situation where there's a managed CPE, a CPE managed by an ISP, talking to the top diagram is showing talking to an ISP managed DNS. So like Comcast in the United States is like this. The bottom one is an ISP managed CPE, which is configured by the ISP to go to some cloud based resolver like 8.8.8.8 over DOT or over DOH for both of these. Next slide, please. And then the same situation with an unmanaged CPE. So this is where the homeowner has installed their own equipment and is overriding what the ISP provided modem or cable modem or network equipment is doing. And both of the configurations are supported here as well. Next slide, please. And this shows the information necessary for classic DNS over 53 and DOT and DOH, that they all need a list of IP addresses that they get from somewhere, either by making queries or getting them directly. And then DOT and DOH need an authenticated domain name, and DO is unique in that it also needs the URI template in order to describe all the different services and capabilities available at that DO server. Next slide, please. And in our document, we discuss ways to discover this information. So of course, for classic DNS over 53, the existing DHCP and RA options are what are used. The yellow shows that what we're proposing is the reference identifier discussed in the document for getting the authenticated domain name. And then the URI templates are also discussed in the document, how to obtain those. Next slide, please. And this introduced verified resolver. We talk about what that is in a couple of slides, but this is the message flow diagram for how that is supposed to work. The purpose of this is to make sure that rogue resolvers are noticed and are rejected by the client. This works by having a list of what the verified resolvers are. And when we connect to a resolver that we're given by the local network, we verify the signatures that we can obtain from its certificate that we get over TLS. Next slide, please. And it shows the pre-configuration that occurs for the verified resolver. Next slide, please. And this discusses what a verified resolver is. So for the auto upgrade case where we switch to encrypted DNS, either DOT or DOH, it's the IP address of that server. And if we're doing ADN, it's that ADN value. We also discuss a situation where in the draft, where the resolver, or I'm sorry, where the server is obtained a certificate, a signature from a certificate authority that is an auditor, so it's separate from the operator. Next slide, please. One of the other things in the draft, and we may want to discuss this and pull this out because it's probably appealing for some other situations, but we need to discuss it more for sure, is when the ISP is operating a DOS server, it may want to reflect back or send back those queries to the ISP operated CPE to help shed the load and get faster resolution inside the home, so it doesn't have to suffer going up and back down the access link. So the mechanism that we have in the document, next slide please, on how to do that is to do an HTTP redirect. Now remember, this is an ISP managed CPE, so the ISP knows what the internal IP addresses are at that home because it manages the CPE, and it can send this redirect back to that CPE. It knows and manages the certificates on there as well. So that can be a DOS server that is signed by the ISP or signed by the auditor, depending which direction we go forward with. But this seemed like a nice technique for getting the ISP DOS server offloaded in much the same way that happens today with resolvers and with DNS mask running in residential CPE. Next slide, please. And DOS servers and URI templates. So this describes why we need them and how we propose to get them. This is a pending issue. There's been some discussion on the mailing list about best ways to do this, best ways to move forward on this. Next slide talks about some trade-offs in different mechanisms that we've considered in the document. And this is something we need some more discussion on the mailing list and in the working group for. Part of the reason I'm rushing through the presentation so we can get some more feedback on this. Next slide, please. One of the values of having a DOS server or DOT server running in the home is that it can identify the different clients inside the house because it can see the MAC address and the IP address of those devices and identify that it's a child's device or a parent's device and provide different filtering either for content or for malware for that device. An IoT device needs different filtering than a kid's PC. So this allows that to occur. If the resolution is at the ISP, it's more difficult. There's ways to accomplish that, but it's more difficult to accomplish that because of the NAT that is typically performed at the residential device for IPv4. Next slide, please. There is implementation that's been done privately. We don't have that available publicly yet. That does nearly everything that is described in our internet draft. And then finally, the last slide is the next slide. Are there any questions?
First up is Jim Reed. Please try in your least Scottish accent, Jim.
I don't have a Scottish accent, guys. Question of the verified resolvers, does that have the possibility for an unscrupulous ISP to the client or the end user that is using a specific set of DNS services or servers?
So our intent there is if you're a subscriber to Comcast, you would tell your client, I like Comcast DNS, Comcast signed DO servers. And then you would use them.
Good. Yes. Okay. Martin Thompson, please.
So I think there's an interesting question there in terms of whether we trust a particular server, and it's kind of sad that we're at the point where you have lists at endpoints. But my question was more about your expectations about updating CPE. My experience with all of these things is that CPE doesn't get upgraded, and so assuming that something like this would happen in CPE, such that it provides the DHCP options that you're talking about, seems a little unrealistic. We've talked to ISPs and they're quite unwilling to make any changes to CPEs for that reason. Anything to add there?
I don't have anything to add there. I'm certainly familiar with that and agree with that analysis.
Okay, thank you. Ralph Weber-Bitte.
Hello. So thanks a lot for that. It's the kind of CPE angle was something that I always thought a lot about. And I, quite contrary to what my predecessor said, is that there are ISPs that manage their CPEs. And on these devices, there are frequent updates. These devices are managed. You can kind of rely on them being up to speed and being there for the subscriber. Now, the question is, you always say sort of do and do when it comes to the connection between the CPE and the ISP resolver and between the client and the CPE. Is there anything kind of that prohibits us to do dot?
All of the slide diagrams do discuss dot and do. The only thing that prevents dot is the HTTP redirect that we're proposing to offload the ISP's DOH server.
I mean, with alt service, we also can, I'm not sure if that is applicable here, but, what's the other thing? I can't remember the name now. There is a possibility from HTTP to get to another protocol, I believe. So maybe we could use that.
We might be able to use that. I'll take a note of that and see if we can work on a way to do that.
Okay, thanks.
And Wes Hardiker, please.
All right. I guess make sure you hear me. Yes. Okay. See, one important takeaway, if based on academic research done lately in terms of TTLs, is that if you move resolvers into home devices and with the incredibly short TTLs that are out there in the field today, which are mostly around 5 minutes, sometimes they're up to an hour, but common practice is unfortunately 5 minutes, you end up suffering with a very delayed query when one of the whole points of using an upstream resolver is to do caching across multiple users so that you end up caching those websites for a longer period of time. So without forwarding, that's something to consider, but the instant you start forwarding, you lose some of the privacy benefits. So there's sort of a rock and a hard place to choose between there.
Yes, that's true. And there's also prefetching that is possible to prevent the delay that occurs with a short TTL. I agree, and that that probably needs some more discussion in the draft and perhaps at the working group too.
Yeah, the problem with prefetching is you end up prefetching the entire internet. So.
Okay, thank you. I was just doing I closed the mic line, but someone had jumped on the end after, and I was just doing a time check with Glenn. Glenn, how are we on time?
I think we should move on.
Okay, apologies for that then. Yep, moving on.
So Dan, you're up next. Let me bring that one up. Here we go.
Thanks. Next slide, please. And next slide, let's go to slide 3. So this is a presentation on DNS server selection with an assertion token. So here we're trying to decide which DNS servers we want to pick. And it's a simple pick, not like what Ted was talking about earlier, where we rotate through, but a static choice. And next slide, please. So what we want to add to the selection is resolver information about its capabilities. So whether or not it does DNS filtering, for example, and to use that in combination with existing PBD-like techniques to decide which server to talk to. And we also would like notification when the policy changes or when the DNS filtering is reconfigured. So if the filtering is turned on or turned off, is to have the client get a notification of that, because it now may want to change to a different DNS server that follows the policies that it likes or has the filtering that it likes. And we also want a way for the human and also for the computer itself to identify and locate the privacy policy statement in order to do something useful with that. And we're not talking about parsing it. We had talked about that before, but we're not talking about parsing it. We're leaving that up to the end user who, as we all know, don't read the end user license agreements, but that still seems to be the best thing that we can do. Next slide, please. So currently we're proposing making this choice on filtering capabilities, and which is DNS filtering for malware and DNS filtering for policy like objectionable content and things like that for, again, a lot of home network sort of situations. And then also QNAME minimalization and whether or not the DNS server you're talking to supports that. Slide, please. And the policy attestation is a signature by whoever runs the DNS server. So if Comcast is running a DNS server, they would sign this, and then they may have an outside auditor who validates that, yes, that's how they set it up, that's what they're really doing, and they could sign this as well. And then these would be signed by registered organizations. And the important point is that last bullet is that the DNS client is configured to trust the signer of the pad object. So that either that is their ISP, Comcast, for example, the auditor, if they like what the auditor has done, you know, Ernst & Young or whoever might be the auditor that validates that. Next slide, please. And this is just the mechanics of the privacy assertion token and how we sign that. In the issues of time, let's jump to the example on the next slide, please. And this is an example of a DNS server that is doing malware blocking, but is not doing any policy blocking. A privacy URL that is accessible for the user to look at, and where the auditor and their URL information is located. Next slide, please. And when either of those change, we're proposing to do a push that is sent back to the client to tell it to go and relook at the new updated privacy policy or the new updated filtering policies that are being used at that DNS server. Next slide, please. And the privacy statement URL is something humanly readable. The high level idea here is changes to that can be noticed when we connect to it or we get the push. And users can review that information and decide if the privacy policy and the filtering agrees with what they want to do. And then add that DNS server to their list of approved DNS servers that is then used in selection. Next slide, please. That's all I have. Any questions?
Oh, we do. Jim Reed, please.
Thanks once again, and again speaking in Scottish. How would these privacy authentication tokens be handled with vanilla DNS where you're not using .dot or DH? Would you expect that the data is going to be DNS side?
I believe we could get them sent down because the signature is outside. The signature doesn't rely on a secure channel, so we could get them sent down. The difficulty is the subsequent queries for class, DNS over 53 could be interfered with by someone on path. So we lose it opens up different attack vectors or wider attack vectors. That's what initially comes to mind.
Okay, thanks.
Thank you. John Todd, please.
Sound check.
Hear you.
Okay, great. So the additional complexity of a push seems optimistic. Was there a reason that something as simple as a TTL wasn't considered?
No, we just thought the push was kind of nice. I agree that the push is kind of risky. The device could be asleep, all sorts of other issues with it not being able to see that push. Certainly, we expect each time that connection to the server occurs, when you join the network, that this information would be retrieved. But yeah, TTL seems like a nice way to solve that too. Thank you. All right.
Thank you. Alison Mankin, please.
Hi. I just wanted to mention, since it's in the references, but you didn't specifically say it, that there's guidance on creating a privacy server policy in the deprived privacy server BCP draft that is with the IASG now. So there's actually specific examples of how you might write one for both .dot and .do.
Thank you.
Okay, and we've run the queue, so back to you, Glenn.
All right then. We're moving along nicely to our next presentation. And then our last presentation. Daniel, you're on.
Yeah, I'm here. Can you hear me?
You can.
Okay. So next slide. So the DNS Resolver Discovery Protocol. Next slide. So basically the motivation is that a DNS resolving service can be achieved using different resolvers, so different identities, and over multiple transports. And each of those resolving servers may also provide some different services like filtering and so on. So if we want to perform a selection, we need to know which are those resolving services that are available. And the purpose of this DNS Resolver Discovery Protocol is to enable a client to discover all the available resolvers, resolving services, so with transport and so on, but also a resolver to also inform a DNS client that maybe a preferred or some alternative resolving service are also available. Next slide. So I had set various requirements just to make sure we agree on what the discovery protocol is. And so I'm going to go briefly through all these requirements before exposing the solution. So the protocol needs to may be used by a DNS client, and that DNS client may be using the regular DNS or the dot or DO, and discover the various resolving services, as well as resolving services may use this protocol also to advertise a DNS client. Some other resolving services are available. That's the first requirement. The second one is that the protocol must be able. The discovery should be dynamic and concern local and global resolvers. And the parameters must be at least the transport parameters, but that may also be extended in the future. Just to mention that, it could be extended with what is being described in the document. Then it's, discovery is one nice thing, but we would like the output of this discovery to be used carefully by the DNS client. So the draft is not discussing that at all, how the selection process is operating, but we do, the discovery mechanism should be made so that the selection process can be automated, involve the DNS client, as well as maybe the other party, which is the resolving service. So in order to ease the automation, we would like the output to be provided in a very standard way. So next slide. And because, the configuration and the selection can also involve the end user, we would like that the output could also be presented to the end user and so be understood by that end user, as well as requirement 6, which is maybe the end user just want to be involved into a subset of those output provided by the resolver discovery protocol. So at some point, you might be able to delegate that to the resolving service to choose what the best option. Then another requirement is if you want to look only for resolving services that belongs to one category instead of the other, maybe you should be able to narrow down the discovery so to a subset of resolving services. In this document, I'm considering the DO, DOT, and DO 53. The information provided by the protocol should be authenticated, and the protocol should not disrupt the legacy protocols, and should also be integrated by the currently used DNS clients. So these are the requirements I used. Next slide. So I suppose we keep the question for the end, unless someone is willing to jump, raise some questions. So the information returned by the discovery protocol. So I think one of the important parameters, discovery parameters, is the identity of the resolver. So how can we represent the resolver? So basically thinking that we can use a host name and a resolving domain. So the resolving domain in this example, if we have a hostname.example.com, would be example.com. It's close to an identity because it's quite meaningful to the end user. It's close to the legal entity in some cases, though it's not user friendly, but it could be used as a key to retrieve information that you want. You would like to present to the end user in some case. And we believe that if the end user has to select a resolver, it needs to have some familiarity with the DNS names. So we believe it's pretty fine. Hostname, on the other hand, we don't believe it's so meaningful information, and we don't expect it to be presented to the end user. And then for an identity associated to that identity, we have a resolver parameters. which concern the transport, the TLS, URI templates, specific services like filtering, and so on and so on. Domain names that are also authoritatives, and so on and so on. So next slide. So at a high level view, we have a resolving domain, like example.com, and under that domain, all the flavor of the resolving service are found. And the protocol is basically using DNS message to discover all those parameters. Next slide. DNS being the language between, understood by the DNS client as well as by the resolver. When the discovery protocol is performed by the client, the first thing is to discover the resolving domains, local and global, and then discover the various flavors of the resolver within that resolving domain. When performed by the resolver, it's like a push. It should send this information back during a DNS exchange, for example. Next slide. So to discover the global domain, well, we're using a similar idea than the DNSSD. We're using a browsing domain and a special domain, which would be dns.rdns.arpa. And this specific domain name is going to list all the globally available resolver. Not the resolver, but the resolving domains. And then for the local domain, the local resolver, usually you've been provided an IP address through a DHCP or Roto advertisement. So you simply do a reverse DNS resolution to that IP address, and you find hostname resolving domain, and that domain should be the one associated to the resolver. That's it. So if you want to discover all the different flavors under a resolving domain, so in this case, the domain is example.com. So you want to discover the DNS service. So you add the underscore DNS.example.com, and you do an SVCB request. So you have the indirections to all the different flavors. So here we mentioned the legacy resolver, the preferred example choice, and the others flavors using dough, for example. So that's basically one way to do. Then if we want to make the discovery among a subset of those resolvers, so only, for example, those implementing dough or dot, for example, we can go to next slide. And so the first thing is that PTR request will list you the different subservices, subset of resolving services. So in this example, we have DO53 dot and do, and then the answer provided by the PTR, you can do the discovery among this subset of resolvers. So you can see, well, the only difference is that in one type you have a service subtype, which is indicated by the port, the standard port of each of those resolving services, and then you have the SVC parameter keys and SVC parameters values that you need. That's going to be useful for the selection. So some of those SVC keys I thought of were so the URI templates, a user interface string, names the resolver is also authoritative for, and maybe names that have a private view on that. So all this kind of information could be added into those strings. So next. Thank you.
Thank you, Daniel. Ben Schwartz, please. Who might once again be having microphone problems. Puneet, how's your microphone doing?
Hi, this is Puneet here. Can you hear me?
Yeah.
Okay. Hi, Daniel. This is interesting. The question, and it may tie in with like the resolver info draft, which Paul and I wrote. But the one thing I do not understand here, maybe I'm missing something, is how is the list of resolvers generated and who is responding to the queries with this information to the client?
So, I mean, can you repeat the question? I mean, we had a burst.
Sure. So question one, who is generating the list of available resolvers here? And question two, when the client is getting the response, which entity or where is the server which is generating this response to the client with the list of resolver names?
So, so for the first question, if we think of a special domain name like rdns.arpa, of course, let's say Google will have to register and ask for his domain name to be pointed at that level. So, is that part of the is that the question?
Okay, yeah, that clarifies your intent. Okay.
So that's in. I'm trying to find out. Yeah, on slide 8, for example, Glenn.
I think Glenn is pulling that up.
Working on it.
So this is a tail relaying a question from Ben Schwartz.
Okay, so
can you tell me which slide you want because they're not numbered?
So at this, I don't know who is going to take care of that, but it could be the IANA, for example, and I mean, globally available services would be represented by resolving domains. So you could have 1.1.1, you could have google.com, or I mean, all those domains. So that was the intention.
Okay, Puneet.
Yeah, and I think also the second question.
So the second question is who is publishing the information? I mean, in next slide. Is that the second question? Who's publishing this information?
Yes.
So if the I mean it's the person responsible for example.com.
No, I'm sorry. So the question was who's responding with the message which contains the list of servers to the client?
So you mean I mean, is the question, is the svc.example.com the same as example.com?
No. So my question is, so we'll have a list populated under resinfo.arpa, and who's returning that list? You envision a new operator there, or?
I expected something shared by the operators, so like IANA.
Okay.
Like the root servers.
Do you guys want to take this offline, Puneet?
Yeah, I'll take that offline.
Okay. Thank you. Relaying from Jabber for Ben Schwartz, he observes that the public DNS server list has 11,000 resolvers on it. Do you propose to publish them all?
Yeah, I don't know what would be the criteria to be entering into that, but yeah. One thing is that I guess that the public DNS got a whitelist, so there's probably, I don't expect to end up with 11,000. I expect only to have the publicly available resolver. So I don't know if there are 11,000 publicly globally available resolver.
Okay, thank you. We have 2 more in the mic line for this before we throw it back to Glenn for the wrap up today. And I apologize if I am mispronouncing your name, but I see Rayhan Joe Ferrali. Maybe best if you say your name when you get on the mic. Okay, not hearing anything there, so let's move on to Harold Alfstrand.
Hi, Harold Alfstrand here. Just a comment on having a global list of servers. If you define a business idea where someone has a monopoly on deciding who gets to play and who's not, you're asking for a lot of trouble. We have enough trouble with the root servers. We shouldn't ask for another list like that.
So yeah, sorry. It's I think the point is on who is able to decide who can come in and not be in. I think this list is going to exist anyway, so as long as it's open and the process of integrating that list, I think it's solvable. I do understand the risk, and it should be considered. Yeah. Thank you for the comment.
You might also want to consider what the CA browser consortium has to go through with validating CAs. It's kind of the same kind of thing.
Thank you, and Rayhan is going to follow up with you offline. So we will now throw it back to Glenn.
Okay, so thank you everyone for the comments, and I'm happy to take that offline or to continue. So
thank you. So there's a picture of our audience for today. So we have 12 minutes left. I would invite people to either the Jabber or someplace else to give comments on how they thought this ran, and what worked and where things can improve, because we have a bunch of other groups that are going to meet later this week that can learn from our experience, being one of the first ones to try this. So the intention in the next couple of minutes is basically if people have some Q&A that they would like to ask of the chairs or of the group in general, the ADs, about where the ADD group is going or what the next steps are, this is your opportunity. Of course, you can always do it in the list.
And Martin Thompson, right up to the mic, please.
So one of the things I saw in the presentations that we had was a lot of concentration on the specifics of discovery mechanisms without a great deal of discussion about what it is that the requirements are and I guess the principles that are driving that. I think Dan got into some of that with his presentation, but I would like to see us talk a little bit more about what we thought that principles were. We saw Tommy with one approach, we saw Daniel and Dan with different approaches to discovery. I'd really like to say, well, are we talking about networks providing this information, or are we talking about something else? Because obviously Tommy's going in a different direction. All right, I'll pass.
Thank you. Paul Hoffman, please.
This is Paul Hoffman. So I was about to say something very similar to what Martin just said. One of the things that drove the creation of this working group was the question of simply, how do I discover whether I can upgrade from unencrypted DNS to encrypted DNS? And I hadn't seen that in any of the presentations today. I would be interested to know if the working group still finds that to be useful, because I would think that that would be easier than almost any of the other proposals. Thanks.
And thank you, Paul. Simon Hicks, please.
My question is sort of from how is it all actually going to work? We're looking here at the detail, but what about the sort of the users? What's their wrap going to be? Where are we going to talk about that?
So Simon, I think your initial comments got cut off. Could you start where you started off again? Sorry.
Sorry, yeah. Yeah, I was asking from where are we going to talk about this from a user perspective, rather than the detail of implementation. Still seem to be sort of lacking the ability to make user choice here.
Not speaking for the entire rest of the working group, but personally, I anticipated being brought up in kind of pervasively throughout. You know, I'm not, again, no hat. This is a tail, by the way, David Lawrence. So no hat on. I'm not, you know, setting direction here. But this seems to me to be something that is a kind of pervasive consideration that rather than standing on its own in a, you know, a separate document has to be kind of brought up in each of the contexts that we're talking about. Chris Box, please.
Hi, yeah, I just want to agree with what Martin Thompson said. Yeah, I think we do need to discuss requirements and principles first. It's just tricky to get agreement on that, but yeah, let's start it in some form.
At the moment, if anybody else would like to put in some comments, maybe Jim revisit his from the beginning of the meeting. Otherwise, we are actually not only going to end on time, but slightly early.
Okay, I'll jump in just for a quick moment to go back to the document from Ted and Yari, starting with the agenda. We need to look at what that impact is going to be on enterprise networks, and maybe the document will have to say something like spreading the query load or the query traffic across a bunch of different servers is something that's not going to go down well in enterprise nets.
Andrew Campling, please.
Yeah, just going back to I think it was Simon's point about the user, the voice of the user in this, and maybe making it slightly complex, that the user might be the enterprise network administrator or indeed the parent. I think some of the discussions touched on that briefly, but I think we need to make sure that this isn't just a slick set of options for clients that completely bypass the user of the device. and assume that the client is all-knowing and all-seeing in this. So we need to make sure that the user is included, and it might not be literally the end user of the device. It might be another entity, that, such as the enterprise admin.
So Dave, is it a wrap?
Yeah, I tried to pass it back to you in our side chat. you are the
through.
yeah, you are
Literally just came through. So hey, thank you everybody for doing this. I think it went pretty well. I was worried first time we tried this, so we peaked out a little over 200 participants. We had that one glitch with somehow preview wouldn't advance to the next slide when it was being shared, but restarting preview solved that problem. So thank you for your patience, and I'll see the rest of you guys on the list. Thank you very much.
Thank you and goodbye.
Thank you. Bye-bye.
You all. Bye.